talking about prime factorization today, and we're going to do some examples of prime factorization. When you're working with prime factorization, you're taking a number and you're breaking it down into factors until you can't break it down anymore. Your bottom level of your numbers will be prime numbers. This is an example of a factor tree, and here's how a factor tree works. If I start with the number 42, I'm going to break that apart into factors that I can multiply together that will equal 42. I chose 6 and 7. You can use any numbers that you would like. It doesn't have to be 6 and 7. It can be any number, as long as you multiply them together and they equal 42. I want you to notice that I circled the number 7. Anytime in my factor tree where I come to a prime number, I circle that one. That's just an indication to myself that I know that that number can't be broken down anymore. It's already a prime number. But I can break down 6, so I break it down into 2 and to 3. So you keep breaking numbers down until all of your numbers here on the bottom of your factor tree are prime numbers. Now once I've broken this down, I can use these numbers on my bottom level of my tree to write an expression to equal 42. And my expression is going to be 2 times 3 times 7, which equals 42. All right, let's do another example. I'm starting with 24 this time, and I'm going to break it down until I have all prime numbers. So I chose to break it down 6 times 4. You could use 2 times 12. You could use any combination of numbers that equal 24. Since 6 and 4 are not prime, I have to break each one of those down. And so I break 6 down into 3 times 2, and I break down 4 into 2 times 2. So now I have the bottom level of my factor tree, and all of my numbers are prime. I have 3 times 2 times 2 times 2. Now, I'm going to take those same numbers, and this is exactly what I just did. So I had 24, I broke it down into 6 times 4, and I broke those down into my prime numbers, and I had 2 times 3 times 2 times 2. But if you notice in this expression, I have 2 listed 3 times. I put a star there under each one. So there's a shorter way that I can write this expression, and it's by using exponents. 2 to the third power times 3 equals 24. And 3 in 2 to the third power, this is called an exponent. It doesn't mean 2 times 3. What an exponent represents is how many times you're going to multiply this number. It means 2 times 2 times 2. I'm multiplying 2 3 times. Alright, let's try it with another number. I picked 100. I broke 100 down very easily into 10 times 10. So since 10 is not a prime number, I have to break it down even further. So I broke it down into 2 times 5 and 5 times 10. So this is my prime factorization, and notice I have all of my prime factors here. 2 times 5 times 5 times 2, which all equals 100. But there's a shorter way to write it using exponents. If you notice, I have 2 listed 2 times, and I have 5 listed 2 times. So I can use 2 to the second power times 5 to the second power, which equals 100. This means 2 times 2 times 5 times 5. Alright, let's practice again. This time I have chosen 144, and the easiest way for me to break it down is 12 times 12. Since 12 is not a prime number, I have to break it down even more. So I broke it down 2 different ways. 6 times 2, 2 is prime, and 3 times 4, 3 is prime. Alright, so since 6 is not prime, I have to break it down into 2 times 3. I already have 2 as a prime number, so I'm just simply bringing it down to the bottom tier of my factor tree. 3 again is a prime number. I'm just bringing it down to the bottom level of my factor tree. 4 I have to break up into 2 times 2. So now my expression is 2 times 3 times 2 times 3 times 2 times 2. Now notice how many times I have 2 in this expression and how many times I have 3 in this expression. I have 2 written 1, 2, 3, 4 times, and I have 3 written 2 times. So I can shorten that expression using exponents, and my number sentence would look like this. 2 to the 4th power, because I have 2 listed 4 times. This means 2 times 2 times 2 times 2. Times 3 to the 2nd power, which means 3 times 3. And all of that equals 144. All right, one last time. I chose 64 this time to top my factor tree, and I'm breaking it down into 8 times 8. I've got to continue breaking that down until I have all prime numbers. So I broke 8 down into 4 times 2. 2 is prime. And I broke it down again. 2 times 2. 2 is prime. These two numbers, number 2s, I'm bringing them down to the final tier of my factor tree so I don't forget them. I'm breaking 4 down into 2 times 2 here and 2 times 2 here. So my final level of my factor tree is 2 times 2 times 2 times 2 times 2 times 2. An easier way to write that is using exponents. I have 1, 2, 3, 4, 5, 6 times I'm multiplying 2, and I can simply write that 2 to the 6th power equals 64.